Hello, everybody. This is Mr. Collins. Today we're going to be taking some notes on oceans. We're looking at Learning Target 52, which is I can describe how oceans and ocean currents affect climate. Some of the major terms we're going to be investigating are ocean current, climate, and density. Starting with oceans, what oceans are made of? Well, we have water, of course, and we have salt. We have salt water. The salinity or the saltiness tends to be highest where water molecules leave the ocean. So how the water molecules are leaving the ocean is water is evaporating and leaving the salt content behind. We can also have the salinity higher where water freezes. When water freezes, the salt is left behind in the liquid water. Salinity tends to be lowest where the ocean is diluted by fresh water. When rivers empty into the ocean, they will make it less salty by the mouth of that river. Locations that receive a lot of precipitation will also have a lower salinity. Looking at salinity and density. The salinity, when we use that phrase, it's going to be the amount of salt that is dissolved in water. So here we have these little blue dots as representing the water. The purple and the yellow dots is representing the saltiness. So if we have the same amount of fresh water versus salty water, there is more material or more matter inside that salt water, which makes salt water more dense. Density, if you remember, is the amount of matter in a given volume. In this beaker, there is more matter than there was in the freshwater beaker. If you remember way back to first trimester, we had a formula for that. D equals M over V. Density equals mass over volume to figure out our density. This salinity or this density plays a big impact into ocean water. Where there is high salinity, there is higher density. And more dense materials tend to sink, while less dense materials tend to float. So if we have lots of salt water, the salt water is more dense and it will sink underneath our fresh water. So in our land surfaces at the water table, the water tends to be fresh water, but the deeper you go, the higher the salinity is. This salinity is one thing that's going to affect an ocean current. Ocean currents is just a big phrase for saying moving water. Ocean currents is the mass of moving water. So our ocean currents, the red is representing the surface ocean flow, and the blue is representing the deep ocean flows. We have a big cycle taking place in our oceans. So what causes these ocean currents and the waters to move in the ocean? Well, there's two major places where water is going to be moving. One is on the surface, our surface currents, and the other is deeper in the ocean, our deep ocean currents. What is causing our surface currents is typically wind. Wind is one of the bigger things that causes our surface currents. Wind, how we get our wind, if you recall, is we have uneven heating of the Earth's surface. That's caused by the different angles at which the sunlight hits the Earth. It's also dependent on if it's land versus water. If you remember, land absorbs energy faster than water does. So the wind, when we have winds, that wind blowing across the surface will often cause surface currents. Here we have the uneven heating of the Earth. If you notice, the gray is representing our continents, and the color pattern is representing warm to cold. Nearer the equator, the surface of the Earth is a lot warmer than at the poles, and so this uneven heating of the Earth is causing wind currents, which causes our ocean surface currents. What causes our deep ocean currents deep in the ocean? It's typically because of convection. The dense water tends to sink and more water flows in to replace it. So on the surface where it's getting heated and the wind causes some of these ocean currents to move, this heated water is also going to be carried from the equator to the poles. As it reaches the poles, it gets cooler, and that cooler water becomes more dense and it sinks. And now we have this cycle of ocean currents. So our deep currents are going to carry that cold, dense water along the ocean floor from the equators back to the poles, where water from deep currents rises to replace the leaving warm water, causing ocean currents through convection. Now, water doesn't flow in a straight line, just like our winds don't flow in a straight line because of the spinning of the earth. This effect, known as the Coriolis effect, causes our water to curve to the right in the northern hemisphere and curve to the left in the southern hemisphere. Water cannot flow in a straight line because of Earth's rotation. The northern hemisphere, our currents are curving to the right, and in the southern hemisphere, our currents are curving to the left. Now, if we didn't have any land, it would be much easier to understand how ocean currents work. But because we have land, these continents get in the way, and our currents end up getting blocked. This is called continental deflection. These ocean currents lead to us to have different climates. Now, if we remember the difference between climates and weather patterns, climates are weather patterns over long periods of time, whereas weather patterns are a day-to-day atmospheric condition. So our ocean currents will change overall climates of certain regions. If we remember looking at average temperatures over a long period of time, we can look at climate as opposed to simply looking day to day what the atmosphere is like on that particular day, which would be weather. So how do these ocean currents affect climate? Well, first of all, if we imagine two places at the exact same latitude, 50 degrees north latitude, Cornwall, England, here's a picture of Cornwall, England, and here's a picture of Newfoundland in Canada. Both of these are at the exact same latitude, 50 degrees north latitude. Here's Newfoundland, and here is Cornwall. But these ocean currents bring warm waters through this Gulf Stream across the Atlantic Ocean and keep the climate of Cornwall a lot more mild than the climate of Newfoundland. Ocean currents also, warm water currents are going to bring warmer climates, and cold currents are going to bring colder climates. Sorry about that. How do these ocean currents affect climate? Well, they also affect climate depending if you are near the coast versus more inland. Here we have two locations. This yellow star is representing Trenton, New Jersey. It typically has highs in the 80s and lows in the 40s throughout the year. At the same latitude, here is Iowa City in Iowa, the green star, which tends to have highs in the 90s and lows in the 5s throughout the year. Notice fairly more mild throughout the year, fairly more drastic temperature changes throughout the year. Typically, Coastal cities or places along the oceans tend to be more mild throughout the year and have smaller temperature changes. The further we get inland tends to be more wild, has bigger temperature ranges. Coasts are mild, kind of like a kiddie roller coaster. Inlands are wild, kind of like the wild thing at Valley Scare. So now it's time to go to your Google Forms and fill in your notes summary sheet, answering these three questions. Number one, what causes surface ocean currents? And what causes deep ocean currents? Question two, how do the Coriolis effect and the continental deflection change ocean currents? And number three, how are coastal climates different from inland climates?